let's begin here. Flipped matrix prequel. Have not solved it yet. You're given a two-dimensional integer matrix containing ones and zeros. Return the maximum number of ones you can get if you must flip a row and then flip a column. Constraints are n and m is between 1 and 250. Okay, so basically you want to find the maximum number of ones you can get if you flip a row and a column, and I think you must flip a row and then flip a column. Okay. So you can't not flip. That's good to know. So here the best method was to flip row 1 and then flip column 1. Okay. So probably it's helpful to know the sum along each row and each column. So we'll generate R and C equals to length of matrix and length of matrix 0, not matrix, return 0. Okay, so that'll be the number of rows and number of columns. So then for R in range of R and for C in range of C. I guess I should generate R sum equals 0 times R. I guess I'm going to do C sums as well, which will be 0 times C. Okay, so then do R sums at R plus or equal to, right, so you don't want to just do V, you want to get the value and C sums at C plus or equal to this. Okay, so I want to get the value. To do that, I could iterate through, I guess go through R for R in matrix, I guess. So it's going to get each row, and then for each row I'm going to, I guess, enumerate that row. So I'll do enumerate, because the row is just an array, and then from the array it will, since I'm enumerating it, it'll give me the column numbers. It'll give it to me in the right order, so like it'll start at 0, 1, 2, 3 until we get to the end of the array. And also I can get the value. The value is what we're going to increment these by, which is always going to be 1, so whatever. This is just more general in case it's not 1, I guess. Right, okay. So then we want to do, alright, that's these two. So okay, what we want to do is we want to compute the total sum as equals sum of R sum, or R sums, oh yeah, it's the sum of R sums plus the sum of C sums. Okay, that would be the total sum. So then you want to start flipping. So if you were to start flipping, I think it would look something like this. So R in range of R, and for C in range of C. There's no reason to enumerate because, well, is there a reason to enumerate? I don't know. I mean, this time you actually want a number though, you don't want like the actual row itself. Right, okay. That's not gonna work. For R in matrix, nope, we have to enumerate this. Oh wait, how do you enumerate I don't know. I really don't know. And then this will be the row, and this will be the row. Okay, cool. And I had to fix that error. This is a clever technique, I think. And I really just want to kind of see if this works. So let's print out R sums and C sums. Oh, is it not? It's not showing me anything because it's saying. Oh yeah. Okay, so this is what we printed. So 2, 1, 1. Okay, so the first row sum is 2, second row is 1, third row is 1, first column is 2, second column is 1, and third column is 1. Okay, seems right. And so the total sum will be, yep. Okay, now, now we need to iterate through each row and column. So the R will tell me the row, and the C will tell me the column. So we want to swap them. So the zeros are going to become 1. So we need to compute the zeros. Actually, the 1s is easier. So the 1s will be, the number of 1s will be equal to R sums. Well, I don't think that's right though. So the 1s would be, I think it's just, okay, I think it's just R sums at R, isn't it? Plus C sums at C. So that means like, so if we're dealing with R equal to 0 and C equal to 0, then that means we're going to flip row 0 and column 0. So let's compute the number of 1s. Then I guess the best answer is 0. Just realized we want to return best. Or what are we returning? We're returning the max number of 1s. Max 1s. So return max 1s. Initialize to be 0 because it could be 0. So yeah, so you just sum these up. So like, you sum up the 1s. So like when I get here for my first input, the 1s would be 3. So there's 3 1s. So that'd be the 1s. And then to get the zeros, we just need to take this 3 plus 3 minus the 1s, right? So like for me, it's going to be 6 minus 3. Minus 3, which is a 1. I'm not sure why that messes up, because if we have 3 here, oh, I guess it's because you have the minus 1, because you have the value right here that you're currently at. But I think you only want to minus it depending on what its value is. So I could put in here I don't know why I wouldn't just enumerate. So you get R and you get row, and then you can enumerate through the row, and then you can get C, and you can get the value. So here we'll subtract the value. So if this was a 0 here, then we have 2 1s, right? So we have 2 1s, we have 3, Yes, I think you always want to subtract 1 because basically if you only have 2 1s and then you do 6 minus 2, you're going to get 4, but you really want 3 zeros. I mean, I guess the only question is, what if your table is like 1 0 1 0 1 0 and then 1 0 0 and then 0 0 1. What's gonna happen here? So number of rows is 3, number of rows is 4, and this side, so you get 7. You get 7 minus 3, which is 4, minus 1, which is 3, and that's correct. You have 3 zeros. What if you add a number here? So then you'll get 8 minus 4. It seems to work for this case as well, so okay, I think it works. So that's your number of zeros. So then what you want to do is you want to say candidate yeah, this is a candidate, but what you want to basically say is take the whole sum and subtract out the 1s because you're going to flip them to zeros, and then add the zeros, and then max 1's update. You have to update this be equal to max. It might be the same as previous, or it might be this new candidate. Off by 1. Okay. So why is it off by 1? Is s equal to 8? 1, 2, 3, 4. Holy smokes. Oh. Yeah, s is just equal to this. Hey, hey, hey. Yeah, 4 is what the sum is equal to. This makes more sense. So then you take like s minus, my result is 5 now though, which is much better. Okay, at least we know our s is right. So then I guess let's go in here and let's print out, so let's print out, let's do a special type of print. Let's do an F print. Let's print out R C with ones and zeros and put zeros. Okay. So we have ones 4 and we have zeros 1. Is that correct? No, it should be 2. Depends how many ones. How many ones? It says it's 4 ones. Oh, it's double counting. So I guess it double counts if where you're currently at, there's a 1. So I guess you need to subtract v. You're getting closer. So 1's 3 and 0's 2, right? I mean, that makes sense. So now you have a correct number of 1's, which is you should have 3 of them. And then the number of zeros is 2, which is, that is correct. So then the candidate will be the 4 minus the ones that you're going to flip, which will give you 1 plus a 0, so it gives you 3, which makes sense. 0, 1. So the answer that works, by the way, is when you have, I think it's 1, 1, 1. It's 1, 1. So when you get the 1, 1. So okay, so when you get the 1, 1, 1, 1 is, here. So there's only, number of ones is there's only 1, 1. Number of zeros is 4, which is true. So then we're going to flip these, right? So we're going to subtract out the 1. I see. So right now I'm subtracting out the 1. So I'm like, let me see. So the 1s are R sums, C sums. We have 1, 1, 2, so 1. We have 1, 1. And zeros, we have R plus C, and our 1s. So that's how many zeros we have. So then the candidate will be you subtract out the 1s, okay? Which is 1. So you're like, okay, let me think. I'm gonna flip this to a 0. And then I guess if this was a 1, if it was a 0 that you flip, it's not gonna really care. Ooh boy. Okay. Ooh, I was getting really excited. Your result is 1, expected 0. Huh. Why? Wait. Okay, so I guess you flip it and then you flip it again. Okay. What's this back? And out V. I don't know if I need to print out V. Let's enter this over here. Okay. So it's 1, 0, which is correct. So then what we do is we go down here. So the sum is 0, I guess. So the sum is 0. So then it's gonna be like, okay, let me subtract the 1, which is 0. And it's gonna be like, let me add the zeros, which is 1. And then since if that was 1, and then you'd flip it to 0, then when you flip it again, it's going to become a 1. But if it's a 0, and you flip it to a 1, then you're going to flip it again, which is yeah. So you want to add a 1 if it's a 1, and if it's a 0, or if it's a 0 initially, it's going to be a 0 at the end. So you kind of want to make it a 0. So you kind of want to do plus 1 no matter what, I guess. So like, no, sometimes you subtract 1, isn't it? So it's going to be plus if v is equal to 1, and it's going to be minus if v is equal to 0. Crikeys, where's my... Okay, here's the map. Okay, 0, 0 with 1s and zeros, true, false. Okay, so it actually works now if you just do, you add 1 if it's currently a 1, or you subtract 1 if it's currently a 0. Which it does kind of make sense, because you're saying you're going to flip all your zeros, but if that was a 0, you're going to flip it to 1, you're going to flip it back to 0, so you have to make sure you subtract off the current one for where you're currently at.